weekly wonder for a while. And we are going to kick off summer by making some
s'mores.
Shooter s'mores?
Yeah.
Marshmallow shooters.
Marshmallow shooters.
Yep, marshmallow shooters. To make your marshmallow shooter, you will need 2 toilet paper rolls,
Oh, what?
a rubber band, a pencil, scissors, a hole punch, and duct tape. And of course, marshmallows. You're gonna take one of the toilet paper rolls and cut a line down it. And you're just gonna make it smaller, basically, so it can fit inside the other one, see? And then you're gonna tape it small. Okay, can you hand me the tape?
Yeah. Here it is.
All right, thank you very much.
Mom, I still like eating these.
I know you do.
Mom, I just sipped it.
Okay,
Then marshmallows.
so now we have a regular size tube and a smaller tube that goes inside. Okay, now what you're going to do is punch a hole on each side. Make them straight across from each other. This is gonna where a pencil is gonna go through it. So you want it to line up. You'll stick the pencil
Oh, you almost did to the marshmallow.
through there, see? And what you're gonna do is you're gonna cut 2 little slits. I cut 2 slits right here and 2 slits on the other side. And you're gonna put your rubber band in those slits. Here's one rubber band, and I have the other rubber band.
No, and there.
And then you put the rubber band on the pencil. So you have a way to pull back and let go. So we want to know, how far can one of these marshmallow shooters shoot a marshmallow? All right, we are starting our marshmallow trials. We have our measuring tape along the ground that is going to help us determine how far it can go. Woo, it went past.
Today we're going to talk about energy. One interesting fact about energy is that energy can't be created or destroyed. There's always the same amount of energy in the universe always. Energy is always transferring around. 2 kinds of energy are kinetic energy and potential energy. In the case of our slingshot, we can both see kinetic energy and potential energy. When you pull back the pencil, there's a lot of potential energy in the rubber band. And so when you let it go, all of the potential energy gets released and turns into kinetic energy and transfers into the marshmallow, and the marshmallow goes flying. Farther you pull it back, the more potential energy will be stored in the rubber band, and the more potential energy that's stored in the rubber band, the more kinetic energy that will be in the marshmallow, which means the marshmallow will go farther, and you get ultimate bragging rights.
This week, we learned about energy and the transfer of different forms of energy. Here's a clip from another activity that we've been doing dealing with potential energy and kinetic energy. Do you ever jump on the trampoline? Think about how the springs act like rubber bands, storing potential energy that we put into it and then springing us up so we have kinetic energy flying through the air. Another thing that I wanted to talk about is the importance of data collection. Collecting data is a great way to get your questions answered. To answer our question, how far can our marshmallows fly, we shot them so many times, probably around 100, and we marked down how far they each went. The more times that you can do an experiment the same way, you can see if your results are typical or if something was just a fluke. When scientists collect data, they run the experiment many times to see if they get the same result each time. looking at those results and looking at a lot of those results, that's when you can start to draw conclusions. Collecting information and data is so important and a major part of the science and engineering process. This week, explore energy with our data collection sheet. We want to see what activities you're doing that involve a change of energy. I can't wait to see your results. Bye!